Hi, everybody. This is Deanna Kosaraju with Global Tech Women. Thank you so much for coming back to Voices 2015. This is version 3 of our annual conference celebrating the accomplishments of women in technology around the world, the week of International Women's Day. So I'm really excited about this particular session because our health is often one of the things that we don't really think about, and we should. As women, we are so busy taking care of everyone else that we forget to take care of ourselves. And we have the cross section of technology, which is something that we all love. So with this session, heart rate variability and the digital health revolution, Ronda Collier from SweetWater Health is going to talk about some of the latest dimensions of heart rate variability and our health. So with that, a couple of housekeeping tips. You can see we have a chat window over here on the right-hand side where you can introduce yourself or you can ask questions throughout the talk. And also, we will be launching a PowerPoint slide here in a moment. And you can drag and drop this PowerPoint slide anywhere on the screen you would like. And we will have to follow along. So Rhonda's going to let us know what slide number she's on, and then we will click the advance button and follow the slides with her. So with that, I'm going to put up this PowerPoint slide so that you can take a look at it. And as you can see here, there's 18 slides. You can drag and drop them anywhere on the screen you would like. And with that, I'm going to hand it over to Rhonda.
Thank you, Deanna. So I'm Ronda Collier, and I'm the co-founder of SweetWater Health, and we do heart rate variability solutions for consumers. So we're going to move just right on into slide number 2. And I just love this slide because even science fiction didn't quite get it right. You know, in 1966, Dr. McCoy wore this giant tricorder around his neck. And then in 1987, in the next generation, it was really looked like a giant flip phone. And here we are today in 2015, and it's a smartphone with a whole variety of actually scanning devices that talk to the smartphone. So it's pretty exciting where we're going with the whole digital health. So moving on to slide number 3. For many of you are not really even familiar with the whole growing digital health ecosystem. We have everything from activity trackers, and I chose this particular illustration because we were at CES this year, and the Consumer Electronics Show in Las Vegas, and they had so many new activity trackers that they had to open a whole new hall for it. Okay, so when we first started going to CES in about 4 years ago, you had Fitbit and you had Jawbone and you had the Nike Fuel Band. Now it's just insane how many people have these wrist-worn activity trackers, which, by the way, are pretty much replaced with your phone that tracks your steps now. Also, we've got just a ton of Android and iPhone apps that help you track calories, your nutrition, what you're eating, and these are just some of the popular ones. Also, wireless scales where you weigh yourself and it just automatically goes into the cloud. Withings, I think, was really one of the first, and now there's a whole ton of those as well. Workout trackers. Many of you have heard of MapMyFitness. Strava is a real popular one for cyclists. And then sleep tracking is one of the really more recent, probably the last couple of years, where you either can wear your Fitbit to see how much you're moving, and then into more involved sleep trackers that actually you attach to your mattress. Okay. Heart rate monitors have been around for a long time, but due to smartphones, they're being more adopted because you don't have to have that, polar watch to go with it. You can actually have a heart rate monitor that talks to your phone. And in addition, wrist-worn heart rate monitors are becoming available, so you don't have to put on that clunky chest strap. Blood pressure cuffs. For a long time, you've had sort of home blood pressure monitors, but now they actually talk to your smartphone and then automatically, once again, put your readings up into the cloud so that you can really easily track it. You don't have to write it down. So moving on to slide number 4, those are sort of, except for the blood pressure, those were really a lot of sort of fun to have, tracking steps and monitoring sleep and sort of those kind of things. But there's really, digital health goes really much more beyond the consumer health devices. You've got 23andMe, which is really personal DNA sequencing, where you swab your throat and send it in, and you can get some DNA information. You've got FDA-approved iPhone cases like AliveCor that do EKGs, where your doctor can actually monitor intermittent heart palpitations, like a PAC or a PVC that you'll never catch in the office because they're so intermittent. We've got the electronic pills to swallow, and they see what's going on. They measure all the gases and hormones and everything in your body, and that transmits to your smartphone. Yes, they're real. You've got the 24/7 patch, which is an EKG. It measures your respiration, body temperature, all sorts of movements and things. And the interesting thing about the patches is what it's doing is replacing what's called a Holter monitor. And that's what doctors put on folks who do have these intermittent heart issues. And it was a big, clunky thing with all these leads all over the place, very uncomfortable and very expensive. And it actually did it on a little piece of paper in the old days. Now we've got these little Band-Aid sized 24/7 patches that automatically upload to your smartphone and into the cloud, and your doctor can monitor that. We've got blood oxygen for people who need to measure what's called their SpO2 and make sure that their lung function's proper, so they're getting enough oxygen into the blood. And glucose monitors, obviously, for folks who have diabetes. But all of these have really moved to their way, and they're serious medical devices into digital health, which is really exciting. It makes not only tracking of these measurements just much easier, but it also allows caregivers as well as doctors to monitor their loved ones and their patients. Okay, so moving on to slide number 5. So what does it all mean? Okay, you've got all this information, and I'm just showing you here a typical dashboard. And I don't know about you, but I look at that and I go, okay, there is a ton of information there, absolutely. But really, what does it mean to me? And I just see it's pretty and it looks cool, but where we're going now is information from the data is the latest sort of catchphrase. Finding something meaningful, meaning information from the data, number of steps, number of calories, how rigorous was my workout, how many hours did I sleep, what sleep stages, and all of that. So next I'm going to segue into heart rate variability. So what is heart rate variability? Heart rate variability in and of itself is the natural variation of your heartbeat. So for example, if your heart beats at 60 beats per minute, it doesn't beat at 1 second intervals like a metronome. And as counterintuitive as that is, what it really does is beat at, say, 0.92 seconds, 0.98 seconds, 1.02 seconds, 1.08 seconds, and so on. And that averages out to 1 second intervals or 60 beats per minute. Also, this we call it a heart rate variability system because it integrates your blood pressure, your thoughts and emotions, your respiration, your environment. Everything is an integrative, interdependent system that affects actually the rhythm of your heartbeat. Okay, so it's not just one thing, it's really the interdependent system. So what does a healthy HRV look like? Well, a healthy HRV we think of a rubber band, a nice fresh rubber band will stretch out and then it will snap back to its original state when you let it go. Whereas a crusty old rubber band, if you can even get it to stretch, it stays stretched and it doesn't return to its original shape. So a healthy HRV looks like a fresh rubber band. It stretches and moves, and then returns back to its original condition. And we'll get more into that in the next slides. And just for those of you who are not familiar with HRV, it's been in research for 25 to 30 years. And there's thousands and thousands of papers in the National Institute of Health database alone. So it's really well researched, well understood, and now it's finally making its way to mainstream. And we're going to talk about why this is important and how it integrates into the digital health revolution. So now we're moving to slide number 7. You know what, I'm going to go back to slide 6 because there's an important point I want to make. So looking up at the EKG picture at the top, so what you have is like the 0.92, 0.98, 1.2, and so on. So what people do that are measuring HRV is we basically capture those variations between heartbeats and turn it into basically a time series. And anyone who's taken statistics is familiar with a time series. You can run statistics on it like standard deviation or root mean square or so on. Also, any electrical engineers out there know that you can take a time series and do a frequency analysis on it to determine the frequency components that are hidden within the time series. And also you can do some things that are called nonlinear mathematics on this time series as well. So it's important to know that HRV is basically the rhythm of the heartbeat, and then it can be processed mathematically in just a whole bunch of ways. And the processing is done on that time series. Okay, so now let's move to slide number 7. So the vagus nerve is the 10th of 12 cranial paired nerves that controls parasympathetic innervation, and we'll get to that on the next slide. But basically it acts to lower the heart rate. Vagal innervation then is a great mediator of the heart rhythm and therefore is a huge contributor to heart rate variability. So you can measure the vagal tone by actually doing one of the statistical analysis on the heart rate time series. It's called root mean square of successive differences. And that 25 to 30 years of research that I mentioned has shown that you can measure the vagal tone using the statistical measure of the heart rate time series. In the last few decades, however, college sports teams, world-class athletes have been using HRV to monitor and measure their training and recovery, because athletes know that recovery is as important as the training. And just for a note, Russia's been doing this for decades, and so finally it's making its way to the U.S. In world-class and professional athletes. So that's one measure of HRV. Once again, that's the statistical, and that is often and commonly used in your apps to measure vagal tone. So HRV in the autonomic nervous system. So the autonomic nervous system is that part of the nervous system that mediates everything from your blood pressure to your temperature to your breathing, so you automatically breathe, your digestion, just basically all the functions that happen automatically, and thus the autonomic nervous system. So the autonomic nervous system has 2 branches. And we have the sympathetic branch, which is also commonly known as the fight or flight response. And then we also have the parasympathetic branch, which is known as the rest and digest branch. So the sympathetic fight or flight branch speeds the heart up, and the parasympathetic or rest and digest branch slows the heart down. And so once again, we've got these 2 parts of the nervous system mediating the heartbeat. And so what we do with this is we take the heart rate time series, the beat to beat intervals, and we run it through a frequency analysis. And once again, I'll go back to the 30 years of research has learned that the lower frequency components of the time series is a reflection of your fight or flight response. And then the higher frequency components of the time series is a reflection of your rest and digest response. And so this is super powerful. With a simple heart rate monitor these days and an iPhone, you actually have a view into your nervous system. And that's just really never been available to individuals before. And it just provides so much information into your systemic health. So we'll talk a little bit more about that on next slides. So I'm going to move to slide number 9. This is very interesting, and I just had to add this for everybody because it's so cool. So there's something called a fractal. And fractal geometry is just abundant in nature. And some of the simplest description of fractals are a broccoli. You have a whole head of broccoli, and you pull a piece off, and the smaller piece looks just like the whole. And you can keep pulling pieces of the broccoli off all the way until you have just like a little piece of broccoli. But structurally, it looked like the whole. This is called self-similarity, and it's a property of fractals. You can also see it in palm leaves, and people have heard about shorelines being fractal and whatnot. So there's a mathematical formula called wavelet analysis, which you don't need to understand because the picture says 1,000 words. But basically, a wavelet analysis is used to analyze that same heart rhythm to see a fractal pattern. So it turns out that a healthy heart rhythm is fractal in nature. So looking on the right at the top picture in green, that is a high-level picture of a healthy heart rhythm. And then the middle green picture is a zoomed up version of the top. And you can see that structurally it looks the same. And you could zoom up on the middle one and keep going and keep going and keep going, and you would see a very similar structure. And so that's really what a healthy heart rhythm looks like. The bottom picture in red is someone with sleep apnea. So you can see that just some minor changes in how someone's even breathing shows a completely different pattern in the fractal structure embedded in the heart rhythm. So another property of fractals is that a really small change in the input, or in this case the nervous system, shows a pretty large change in the actual fractal structure. And an example of this that a lot of people have heard of is the butterfly effect, where the butterfly that flaps its wing in Brazil changes the weather pattern because the weather pattern is chaotic, which is tied into fractal geometry. These two kind of go hand in hand. So small changes can create large effects. And this can be important as you try to use HRV to see early disease detection. So going on to slide number 10. So HRV, what does it mean to you? Well, HRV is an indication of many things, but one of which is your resilience. This is the ability of the nervous system to respond and then recover from physical and psychological stressors, okay? An example of this that you can understand is when you're lying down and then you stand up, your nervous system needs to kick into fight or flight just a little bit, or sympathetic, to speed your heart up to equalize your blood pressure so that you don't get a head rush and fall over. Then once you've been standing for a moment, your heart rate should return to normal and your blood pressure should equalize. So this is an example of somebody with a high heart rate variability. It means that they're able to respond to standing up and then recovering to being standing, okay? Another thing that I think a lot of people aren't aware of, you may have heard that here in our modern era, we're always stressed, but animals in the wild, stress is sort of part of nature, and animals in the wild, when they get stressed, they actually do their fight or flight thing. They run away because their life is in danger, because maybe a tiger's chasing them. And then what they do is once they're safe and the danger's over, they actually tremble and shake off the stressful energy that you've accumulated running away from the tiger to save their lives. Humans, on the other hand, mentally create situations where their body acts like it's in danger. I mean, let's face it, there aren't a lot of saber-toothed tigers these days for us to really run away from. What we do is perceive situations that are not life-threatening. We go into fight or flight, and then most importantly, we don't shake off that excess energy. So what happens is our bodies accumulate this stress energy over and over and throughout our lifetimes to a point where we end up with chronic stress. And so once we do sort of accumulate that chronic stress, our ability to respond and recover from even our perceived, much less our real stressors, becomes impaired. And that shows up in a low heart rate variability. And I should stop on that for a minute. It's counterintuitive because we think, oh, a low heart rate, that's healthy. Athletes want to see their heart rate, down below 50, and that's good. The opposite is true with HRV. We want to see a high HRV because that is indicative of a really responsive and elastic nervous system that allows us to navigate through life and deal with not only real danger, but perceived danger and recover from that. Okay? So the sympathetic fight or flight response, as I just mentioned, has really become chronic in our modern day because we just perceive things as dangerous that aren't, and then we hold on to that stress energy in our bodies and don't release it. And according to some of the leading medical institutions such as Mayo Clinic, Harvard, Stanford, I mean, you can look all this up online, even more than 90% of all disease is caused by the root of chronic stress. And so it's really, really important that we manage our stress. One of the issues, though, with stress is that because our brains are giant pattern matchers and filters, we may not even notice we're stressed. So let me give you an example of why the brain is a big pattern matcher. Otherwise, I would be sitting here feeling the chair on my body, the clothes on my body, the earphones would be bothering me. I would be so aware of everything going on with me that I would really literally be unable to function. And so what the brain does is take familiar stimuli and just filter it out, okay? So when we slowly become more and more stressed, the brain filters it out. So we don't even know it. And we move through life thinking that we're relaxed when actually our nervous system is in a chronic sympathetic or fight or flight response. And so that leads to illness and hypertension and heart disease, even in healthy athletic people in middle age. Okay? So we really want to be able to objectively measure some of this stuff. Also, chronic low HRV is indicative of bigger problems. And I really, really want to have you keep this image of this iceberg in mind, because this is really what HRV allows you to do. It allows you to see the tip of the iceberg of something large that either is there and you don't know it yet because it hasn't manifested in disease, or it's brewing, okay? And once again, that goes back to the sort of the fractal nature of the nervous system, a healthy nervous system, and small changes, just small perturbations in the nervous system will eventually show up in heart disease, hypertension, all sorts of things. So we can catch that early using heart rate variability. Okay, I'm moving to slide number 11. These are just some other really important factors. Now that you've learned about heart rate variability, it's really important that you understand these aspects of it. And so I'm taking this opportunity to just run this by you. So HRV has a circadian rhythm. So it does vary in a 24-hour period. It actually also has a biorhythm, which varies throughout the month. And so as you start measuring your HRV, you want to keep this in mind so that you are aware of this rhythm. Otherwise, you might go, oh my God, yesterday it was so high and today it's so low. Well, yesterday you took it at 10 a.m. and today you took it at 3 p.m. during kind of the sleepy time of day. And so you'll see just a natural difference for that. Also, HRV is dependent on body position. So once you start tracking your HRV, you either always want to do it lying down, standing, or sitting. So you really want to compare apples to apples with this. And then thirdly, HRV is dependent on the length of the measurement because your nervous system is flexible. It's managing your entire body. It's keeping your temperature mediated, your blood pressure mediated, your breathing, everything, all your organs functioning. And so you really want to do the same length of reading, okay? Now, in the medical world, there are a couple of different types of readings. There's short-term reading, which is 5 minutes. And then there's what they call the long-term reading, which is 24 hours. Now, that doesn't mean you always have to do 5 minutes. You can sit and actually do an hour reading while you're working at your desk or driving or doing whatever, watching TV to see if you're actually relaxed. That'd be a good one. Are what you're watching on TV calming your nervous system, or is it actually putting you into fight or flight? That would be really good to know. So the moral of that story is HRV should be taken at the same time of day, in the same position, and if you're really tracking it, for the same length of time. Athletes do it for 3 minutes in the morning, but we really recommend a 5-minute reading once you start tracking it. that keeps you aligned with the medical sort of definition of short-term HRV. Okay. So why don't you know about this? Well, these are some, it's great. These are some legacy HRV products. And these, because HRV is computationally intensive, as I mentioned, we take that beat-to-beat time series and we run it through a lot of math, statistical, frequency analysis, or even fractal and nonlinear type analysis. So you needed computers, and even back, God, can you imagine 20 years ago what they did? They had a whole IBM mainframe doing their heart rate variability, which was not feasible for consumers. So it really didn't make its way to the mainstream. And also these devices cost anywhere between $40,000, coming down to about $1,200 in the last couple of years before you were able to have them on a smartphone. So there's really a good reason why you haven't heard of heart rate variability. Also, the practitioners that used these devices didn't take into account the circadian rhythm, the biorhythm, or the position. And so what they got was a lot of information that, you just couldn't make a lot of sense of. Heart rate variability requires education. Once you get it, you kind of got it, but it does have a little bit of a learning curve, which I believe is worth it given the really insight you have into your systemic health. So now we have the ability to understand this stuff and glean some meaningful data from our at-home consumer heart rate variability capability. So now I'm going to move to slide 13. So now in 2015, as I mentioned, individuals have the ability to measure their heart rate variability at home and learn what habits they're doing cause them to go into fight or flight, which, as I'll just remind you, medical institutions believe is chronic stress is the weak link in 90 to 95% of all disease, okay, including diabetes and obesity. So HRV is going mainstream, providing meaningful feedback. And you can see the app here, which is called SweetBeat Life. There's just a little stress meter. So it's small on your slide, but you've got low stress blue and all the way up to a red stress red. So you're getting something meaningful from that. Also, athletes use it and they have a special graph that tells them where they are in their training. Okay. If their HRV is high relative to their particular training line, then they know to train as usual. If it's low, then their nervous system has not recovered and it will actually not behoove them to go train hard. We can recommend, a low exertion day or even a rest day, because as athletes know, you must have proper recovery in order for your muscles to rebuild and get stronger. Okay. And on that note, there is clinical research that shows that adding heart rate variability to professional and even amateur training regimes results in better outcomes. So when we first started SweetWater Health, there were 3 heart rate variability apps in the App Store. That has grown to about 30 this year. And we are so excited about that because HRV is so important. I just can't express to you how grateful I am that this is making its way to mainstream, because it's looking at your nervous system. Doctors are concerned with your organ function, and rightly they should be. But now you can monitor the system that controls those organ functions at home and see early perturbations of the nervous system before it shows up in a liver, kidney, pancreas, lung, or heart problem. Okay? So let's move on to slide number 14. So I'm going to circle back around to HRV and digital health. Okay? So with all of the activity trackers, we can monitor the number of stress steps we have. And I just want to take a moment with that. And I don't want to act like none of this is important, because it all is. All right? Especially for people who don't move a lot. Knowing how many steps you're taking in each day is really important. And this has grown in importance because people work at home and telecommute a lot. And so you're not even walking to the car or from the parking lot to the office or out to lunch with your friends or walking around the office. You're going a few steps here to the kitchen or a few steps there to the restroom, and that's it. And so the number of steps in activity trackers is really important for people who aren't getting that regular walk through the park or off to the gym or hike or cycling or whatever. Okay, so knowing the number of steps is really important. But that's pretty much what these things do. They sort of estimate how much you're moving, which is really good. They estimate the calories, but once again, it's an estimate based on just movement and weight and things like that. So, but it's all good. The sleep stage estimates, once again, is very interesting, However, are you getting the restful sleep, the sleep that replenishes the nervous system? I don't know. So, but sleep staging still, at least you're starting to pay attention and understand the mechanism of what's supposed to go on in your sleep. Okay. So, we also have, lots and lots and lots of apps where you can enter what you're eating. It monitors your nutrition, and how many calories you've eaten. At least this is reasonably accurate these days because, man, they have scanned in all the foods from Trader Joe's and Costco and Safeway, and they have the calorie counts for those. So it's a really great way, and nutrition, for you to track not only how many calories you're eating, but the nutrition behind what you're eating. We've got distance, we've got MapMyFitness, we've got Strava, we've got, Runkeeper. We've just got a whole bunch of apps to track your distance and activities when you exercise. And these are fun. Also the MyFitnessPal in particular, and sort of the Strava and MapMyFitness, sharing it with friends can sometimes motivate you. And so that's really, really a good thing. So these are all good. And then we've got heart rate, once again, which, for the most part, though, if your heart rate is below 85, you're probably, just kind of want to know your heart rate. There's not a lot of information in that. And once again, I'm not discounting knowing your heart rate, because if your heart rate starts being 100 beats per minute, you need to know that. And that is definitely an indication of something wrong. So, but all of these things are just really good, and they're really popular. You can, I think, go into Costco now and buy activity trackers. And I'm just so grateful for all of this, because what it means is that we're becoming our own health advocates. In our parents' days, we basically did whatever until we got sick, and then we went to the doctor, and the doctor told us what to do. Okay? And we sort of put the doctor on a pedestal, and actually relied on the doctor to take care of us. Our parents' generation also are kind of a quick fix generation, and not everyone, and there's nothing bad about it. It's what everyone learned at that time. Antibiotics were relatively new in our grandparents' time, and so, man, we have a quick fix now. We can take a pill to solve all kinds of diseases. But what that has done is created a quick fix culture. Okay, we want a pill for everything. We don't want to exercise and eat right. We want a diet pill. We want something that magically makes us skinny and beautiful. And so it's just so exciting with people getting into how many steps they're taking, what are they eating, how are they sleeping, because it brings ownership into their own health. And it also allows them to become an advocate for, say, a parent or a family member who's getting interested in this as well. I'm personally becoming an advocate for my mother, who's 79, and even though she's in great health, stuff starts happening, and so I'm giving her a wireless scale so that we can, monitor her weight, because there's been some sort of curiosity about that, and also can go online and look at all her test results. So it's just so exciting. Moving on to slide number 15. So in addition to these popular consumer products and the fitness trackers and sleep trackers and all of that, we have what's called biohacking and the quantified self movement. Okay, So, and I'm really not joking here on these pictures I chose, because there are oxygen bars people go to sort of increase performance. There are magnetic brain stimulation to help increase cognitive performance. And yes, intravenous vitamins is another way that people actually go about increasing their performance and trying to boost their health. You've got, all sorts of folks out there promoting their sort of version of how they've overcome chronic diseases. I mean, a lot of these people are really amazing and have come up with techniques that work for them to either lose 100 pounds, increase their cognitive abilities, just feel better. And there's many more than I'm showing here. And that's sort of the biohackers that have created these venues. And they have tons of following. There's millions of people following, Ben Greenfield, Dave Asprey with the Bulletproof Executive. And then we've got what's called the Quantified Self movement, which is a really growing movement. We've been involved with them for 4 years now, and they've gone from sort of a really small group to some really large international conferences of people that just measure what's going on. They track everything, the temperature of the room. They do, am I performing cognitively better when I fast? I think I am, but guess what? I did some quantified selfing and I realized that I'm not. You name it, they're tracking it, okay? With the goal of being healthier, happier, and having better performance, okay? So there's just so many people, venues, tracking devices, you name it, it's out there, okay? The issue is, though, it's not one size fits all. So what worked for, say, Dave Asprey may not work for everybody else, though I will say a lot of people are getting some good results from him. But one size does not fit all. So we have to keep that in mind. So we're moving to slide 17 now. So as I mentioned, so which venues? How many steps? What am I eating? What kind of food am I eating? What's my fat versus carbohydrate versus protein ratios? All of that. One works for one person and other combinations work for another. Which ones are really making me healthy? Okay, so you want to do some objective measurement here to see what works for you. And so besides the cholesterol reading, which you probably do once a year, which is a blood test. So I didn't include that here because it's not something that you generally can do at home. Though I'll take this opportunity to mention that we're getting there with mail order blood tests that are actually really reasonably priced for consumers to go and get a custom-made blood test that maybe their doctor's reluctant to order for them. So besides your cholesterol, which you'll want to, by the way, be your own advocate, ask your doctor, especially if you have heart disease in your family, to measure your small LDL particles. And I encourage you to go look this up. And pay attention to your HDL-LDL ratios, as well as your triglycerides. And understand that diet and exercise are your first line of defense for high cholesterol, and especially LDL and triglycerides, rather than going on medication. So this is kind of where we're going. But the things you can do at home are measure your blood pressure and use a wireless device that really tracks it for you. So it just makes it so much easier so you can track your blood pressure and have a chart without having to write it down, because just people don't do it. They sort of take their blood pressure and then go, okay, I'm good today, but they're not tracking it. The wireless scales, another great way to see what's going on, whether a certain nutrition program or diet or ratio of fat to protein to carbs is working for you. And then, once again, taking your home heart rate variability. These three together will give you a real deep insight into your general systemic health, and will give you an early alert system to something going on. So if you've been taking, say, even once a month, you do your blood pressure, you weigh yourself, and you do your HRV at the same time, your 5-minute reading, the same position. And then you've been doing this, say, for a couple of years, and suddenly you get this chronic drop-off in your HRV, or obviously chronic increase in your blood pressure, or suddenly you start ballooning out and gaining weight. Then you have sort of a check engine light, if you will. And it's an indication to make an appointment with your doctor and go get a physical. So in conclusion, on slide number 17, so digital health, particularly mobile health apps and devices really are changing the way we take care of ourselves. We really are taking charge of our own health. We're actually able to go into the doctor like I just did and say, I want a test to measure small LDL particles because I have heart disease in my family. That was not a standard test that would have been ordered. And so absolutely she did that. And so we are becoming our own advocates and the advocates of our family and some of our parents, which is really, really great. We can really help them a lot get the treatment and the proper testing that they need. Okay, so personal health monitoring devices give us a lot of data, including exercise and nutrition. The quantified self and biohacking programs and devices provide just a plethora of really new and exciting self-improvement techniques and programs and measurements and devices and things like that. But because one size does not fit all, we do need to monitor our actual physiological health metrics, such as weight, blood pressure, and heart rate variability. And, I'm just so, like I said, I'm so grateful and so excited at the, I think more than 30 apps on HRV, and that HRV has finally emerged as a early indication health metric. And it's really a must-know physiological and psychological metric to see how your nervous system is doing for early disease detection. And then I'll just say a large thank you on slide number 18. I really, really, really appreciate being included in this awesome program, and I really, really appreciate you joining me today. Thank you.
What an amazing presentation. I've learned so much, and I'm looking forward to going back and watching the recording again, and also sending it to some people that I know who should be tracking this very important marker, which I don't think many of us are aware of. And so I'm really grateful to you for bringing this to our attention.
Thank you.
So does anyone have any questions that they would like to ask? You can use the chat window over on the right-hand side. So I have one question while we're waiting to see if anyone has any questions. The first one, and you mentioned it briefly, is there differences between men and women? Is there certain things that women should be more concerned about as they're going through this process and trying to set that baseline for whether or not the engine light comes on?
That's a great question. So first of all, HRV is age dependent and gender dependent. Okay, so women certainly should compare themselves to themselves, really. But so they need to keep that in mind. They're going to be different from a man. And actually, at certain stages of life, women tend to be a little bit more resilient. They believe it's because men traditionally have had the stress in the workplace. So that's changing a little bit. But for women, moving through their 40s and into 50 can have some hormonal imbalances. And so this could show up in heart rate variability. So if you start getting, like the 3 p.m. tired's all of a sudden in your life, then you really want to start tracking that and see what's going on with your nervous system. Basically, I would start doing morning readings and see what's going on. So you could definitely detect if there's a hormone imbalance going on by seeing what's going on in your nervous system, because it's tied to, all of the organs, including, the thyroid, the pancreas with insulin, liver, any of that. And of course, any sort of impending early detection of heart arrhythmias would show up in HRV. What happens is that as you get older, or now you're in your 50s and you've had sort of an undetected chronic stress all your life, is that your HRV starts decreasing before you start having heart disease. So it becomes sort of a stiffening, if you will, of the nervous system. And so your heart rhythm becomes more regular. And there are folks out there that use HRV as a preemptive measure and have seen really intense fit athletes with a low HRV then have heart failure that was indicated by the HRV.
Hmm. And I think we've probably heard a number of those types of incidents in the media where you see a relatively looking fit person
That's right.
who hasn't perhaps measured this key indicator, and it may have led to some early warnings about their heart condition.
No, right. Adrenal fatigue, which you can't find really in the NIH database, but it's very real for athletes. A lot of these endurance athletes tend to be type A, and nothing wrong with that. But what they do is they work out, and they feel guilty if they take a day off. And what they've done is drive themselves into what's called adrenal fatigue, where basically their adrenal glands are just overloaded, and all the it's so cool, actually. Everything's interconnected, the pituitary, the adrenal gland, everything. Cortisol production, insulin production, all of these things feed back on each other. And so what these athletes do is drive themselves into adrenal fatigue. And so all these mechanisms break. They could be on just a streaming cortisol that doesn't respond to the feedback mechanism to shut it off. Adrenaline might be out of whack. Insulin, all of this. And so they are actually become unable to exercise. It's really, yeah, we've had a few of our customers who have gotten to that point.
Really
it is.
Okay. Well, I don't see any other questions from the audience, so I want to take this time and thank you very much for an amazing talk, and I'm sure a lot of people will be taking advantage of the recordings. We have the link to the slide share up here to view the slide presentation, and also contact information for Rhonda should you have any questions about this presentation later on. So,
Okay.
Rhonda, I hope that we stay connected on Global Tech Women, and I hope that we find ways to collaborate, because
Yes.
I think what you're doing is amazing, and we really need to get the word out to women in technology around the world about how important this is.
Oh, I will mention we're founded by 3 women engineers. SweetWater Health is founded by 3 women. Yeah.
Well, maybe we could have them on. That would be a heck of a conversation. We should try
It
to do
would,
that.
it would. No, we love it. We love it.
Oh, awesome. Okay.
Yeah.
See,
Yeah.
I'm learning more all the time.
Yes.
Okay,
Yes.
thank you so much, Rhonda. I
Okay,
really
Deanna,
appreciate
thank
it.
you so much for having me.
Okay, take
Bye-bye.
care. And thank you to the audience. I hope that you will join our next session, which is on integration and agile. And so I'm getting ready for that one. It will start in about 12 minutes. So thank you. Bye,
Okay.
everybody.
Bye-bye.